Hi, welcome to the Aruba OS 8.3 how-to video series. This is the 15th and final video in a 15 video series that covers the initial configuration and deployment of an Aruba OS 8.3 Mobility Master. This video specifically is going to cover one of the most important and critical features of Aruba OS 8.3, and that is the ability to support a live network upgrade. This in effect allows us to upgrade the controllers and the access points in such a way that it's not disruptive to the clients that are associated and passing traffic through those access points. Now, to support this feature, we're actually using two other features that Aruba OS 8 supports. The first one is Air Match, which you can read about at arubanetworks.com if you like. But that is the ability to survey the air over a longer period of time and then dynamically, one time a day, assign a channel plan to all of my access points that are deployed underneath that Mobility Master. This lends more stability to the network by allowing the APs to run on a specific channel without being reactive throughout the day to bursts of interference. Older adaptive radio management systems that we used to have could tend to be fairly unstable if there was a lot of surrounding interference. What AirMatch tries to do is instead it takes a survey and keeps track of all the APs in the deployment and then creates one plan that gets applied to all the access points one time a day. So in effect, while we're still reactive to very high levels of interference or noise, and if we see that the channel becomes unstable, the APs will still move, but generally speaking, the goal is stability. The other feature that we're using with live upgrades is the controller clustering ability, and that is the feature whereby access points have a primary and a standby tunnel to one controller over each tunnel. And if that controller that's terminating the active tunnel goes down, all of the user traffic can instantaneously switch to the standby tunnel without losing any traffic. The goal with this is that because we're sharing state between the controllers, that if we need to rebalance the network deployment, we need to rebalance users or access points across the controller cluster, we can do that dynamically without impacting the user session. We're going to take advantage of using how AirMatch builds the channel plan and how we use clustering in such a way that the Mobility Master, when we initiate a live upgrade, will do a coordinated process by which, when it decides the controller that it's going to upgrade first, it will basically take all of the AP tunnels and user traffic and move them within the cluster to another controller that is not going to be upgraded. So in effect, if these two APs on the top are terminated to VMCA1, it would essentially move all of the AP tunnels and user tunnels from VMCA1 over to VMCA2. Once VMCA1 is empty and there's no users and no access points, the Mobility Master will take it offline and do an upgrade. When that virtual mobility controller comes back up on the new version of code, it will essentially move those APs. It will take one RF channels worth of APs and move it back to VMCA1 that's running on the new code. The idea being that if these four APs are covering roughly the same area, I can take one of these APs down without disrupting my clients. So before I take this channel 157 AP down, I will move all of the user tunnels over to, I'll steer them towards a different access point, or we'll re-terminate the user traffic across a different mobility controller. Once this AP is empty, we will push new firmware to it, reload the access point, and when the AP comes back, it will be terminated on the new controller. Once that AP is up, we'll start slowly shifting users over to the new AP, and then we'll repeat that process for the remaining APs. The goal being, we're taking, in this instance, one AP down of the four so that we never create a huge coverage gap, but we can essentially keep all of the users connected to at least three of the access points. And if you scale this out towards a large enterprise deployment, you could actually see that we could take multiple APs down every time we do an upgrade, just so long as we maintain proper coverage. And that's using AirMatch, that's using Client Match to steer clients, and that's using the cluster functionality of the Mobility Master. So what I want to do to demo this is I want to show kind of what steps you take when you do a migration or a live upgrade. I also want to, sorry, I'm copying over a build number to paste in there when we're ready. That's not the right one. Where did it go? I will find it in a little bit. But what we want to do is find the node that has the cluster that we want to upgrade. Now, because in our original videos I had essentially one AP in every cluster, if I were to do a live upgrade in a cluster that only had one AP, there's no way to avoid an outage. I don't know why that went away. And so what I need to do is create at least 2 access points that are covering the same area. And so I essentially moved the AP that was in Campus B, I moved it up to Campus A. So now when I look at Campus A, I can see 2 access points that are covering the same area so that my client has somewhere to roam when one of the APs upgrades. Now, the other thing that I want to look at, just to show at the underlying level what everything looks like, I'm gonna SSH into all the controllers. You can do a show switches to see what version everything is at. And you can see that I've already upgraded my mobility masters to build 64601, but all of the mobility controllers themselves are actually running on the older version of code. Now, to upgrade a mobility master, you don't have to worry about taking a mobility master offline and it disrupting your clients. So long as it's not taken off for a long period of time, say multiple days, generally speaking, the access points and the user sessions will still work as they always have. So when you need to reboot your mobility masters for a firmware upgrade that you're going to do or that you're going to use for a live upgrade, it's fairly non-disruptive to your users. You might maybe not want to do it during your peak hours, but you could certainly do it early in the morning and the afternoon. Chances are no one would notice. But to upgrade the controller, you can essentially go to the mobility master, go to maintenance. You can then upload it via TFTP, local file, SCP. This is fairly standard. You can find this in the user guide, and this process really hasn't changed in quite a while. But you do need to make sure that when you do your code upgrades that you get all of your mobility masters upgraded first. So if I were to look at all of my mobility masters, I could do a show image version. I can see that it's running 64601. I can see the same thing for my backup if I do a show image version. And I can see that it's also running 64601. And then my L3 mobility master that is backing up over in the other data center, I can do a show image version and see that it's also running 64601. So this part looks all good. The other thing that I want to verify is, just for the purposes of this demo, I want to make sure that all of my clusters are in the right state. So if I do a show LC cluster group membership, show LC cluster group membership, there we go. You can see that they are L2 connected. I'll do the same thing over here. So this is what I want to see in my cluster. I can also do a show AP BSS table, and this will tell me where the primary tunnels are. So the A basically stands for the active AP anchor. I can also do a show AP BSS table standby, and this shows me the standby tunnels. So this SA tells me that these are standby tunnels. The A tells me that the active tunnels, and I can see the same thing, which should be the opposite on the other controller, because I have 2 controllers in here in this cluster. So I can do a show AP BSS table to see the actives, and then I can do a show AP BSS standby, and that will show me the standby tunnels that are up. And this should basically be a mirror image, so you can see I see AF 10, 11, 12, 0, 1, and 2. And if I look back over here, my actives are 10, 11, 12, 0, 1, and 2. So I can see that my tunnels are balanced across the controllers, and that tells me that all of my clustering is working the way I want it to. So that's kind of my backup check. So I'm going to go ahead and initiate a live upgrade. I'm going to go to the node that has the cluster that I'm going to upgrade. I'm going to hit configuration, and then I'm going to go to tasks and upgrade cluster. Now it's going to show the cluster that's in here. You could have multiple clusters within the same node, and so you would just pick which cluster you want to upgrade. But you can see I've got 2 controllers, 2 access points running on build 64562. I'm going to hit next, and what I want to do is upgrade to this version, which is, let me copy it over, is this version here. So my SCP server is 100.143. This dot just tells it to look in the main folder, but if I had a big SCP server that had the firmware nested inside some other folders, I would want to put that proper path. I've got SCP as the protocol, my username to log in, and I will re-enter my password. Now what's going to happen is I can choose which partition I want to upgrade, which I know right now they're all running in partition 0, so I'll go ahead and select partition 1. But if you're not sure and you don't want to check, you can just choose the alternate partition, and what it will do is it will check the controllers and then upload the firmware to the partition that is not currently the active booting partition. So once I feel good about everything, I'm going to go ahead and click on the upgrade cluster. Now what's going to happen, the Mobility Master will do an AP image preload to the APs and push the new firmware to the APs before they reboot, so that when they come back up, they won't have to communicate to grab new firmware that'll already be there. They just have to reboot and come up. Additionally, it's going to start looking at how the APs and the clients are load balanced. Now again, there's not a whole lot on this. There are 2 access points and there are 2 users that are on those access points. So there's not a lot to see, but you do need to give this a little bit of time, this upgrade status page. So you can go and hit close, and then once you see this change to in progress, it pulls up the cluster upgrade status dashboard. And you can follow along. This page will refresh on its own. You can click around to other pages if you maybe want to go look at something else and then you want to come back to it. Let's say I want to go to the dashboard for Campus B, look at Air Group for a second, but then I want to go see what the status is of my cluster upgrade. I'll go back to Campus A, go to Config, then I will go to Services, and in the cluster you'll see the in progress is posted here. This pulls up the upgrade page. Now what it's doing is it's copying the image over to the controllers, and then as the Mobility Master manages the live upgrade, it will essentially take one controller, move all the APs over to the other, then it will do a reboot, it will make sure that it comes up, and then once it's up, it will slowly start to move one AP at a time. In this deployment, it'll move one AP at a time over to the new controller. When both access points and all the users are over to the newly upgraded controller, it will take that last controller and move it offline. So this page here tells you where you're at in the live upgrade process. Now there's not a lot to look at here, so I've only got 2 controllers, I've only got 2 access points, but these bars become more critical as the size and scope of your deployment increase. So instead of kind of having to watch this overall process for 2 controllers and 2 APs takes about 20 minutes. A lot of that time is kind of the file transfer and the controller reboots and AP reboots, but it's fairly monotonous to watch. And so what we can do is I'll let this run in this dashboard, but I'll speed it up in the video so you can kind of watch it every time it refreshes, and you can track how the bars move down the screen. So we'll come back after we get this finished, and I'll speak to some conclusions. Okay, so the upgrade process is complete. If you were able to stand the minute or so of watching this in high speed, you saw that one of the controllers went, then both APs went, and then the last controller went. And if we we'll go ahead and log back into the controllers. We'll make sure everything looks good. I can do a show LC cluster group membership. You can see that they're both L2 connected. I can also do a show AP BSS table and see those are not broadcasting yet, so this must have been the one that went last. Whoops. So the tunnels are not stood up yet. We'll check this guy though. All of his tunnels will be. Excuse me. Do a show LC cluster group membership. Show AP BSS table. See all of the BSSs for both AP there. Eventually, as this second controller comes up and the cluster manager moves back over, we'll see everything rebalance. So I can't think of anything else that will be worth showing. I'll come back in a minute or so. But the main thing to be aware of when you're doing a live upgrade, while it is certainly reliable, the one or two things that would be worth noting. I certainly wouldn't want to do a live upgrade during the peak of my users. For example, if I'm a college or a university, I wouldn't necessarily want to do a live upgrade when all of my students are on campus and active in class. However, that being said, it is nice that I can take an upgrade during off-peak hours without really having to take an outage. I could send an email out and I could say, hey, we're doing an upgrade, something may happen, we may have to roll back, I'm not really sure, but it should be fairly transparent and most people won't notice. Or you could go ahead and do the upgrade and not tell anyone, but just do it off-peak hours. The other thing to note too is the larger the AP count and the larger number of controllers that you have, the longer that this process takes. Start to finish for the 2 controllers and the 2 APs, it took about 18 to 20 minutes. Again, most of that was waiting for the 3 or 4 minutes for each AP to reboot, waiting for the 5 or 6 minutes for each controller to reboot. But the more APs and the more controllers you have, the live upgrade could take quite a bit longer. For our event network that usually had about 250 access points and about 300 users whenever we do the live upgrade during Keynote, that process usually takes 2.5 to 3 hours. So it's not an exact number as far as how many APs and users that you have that extends the time, but it's certainly related. Now, the denser the AP count, the faster it can reboot. The fewer channels you have, the faster it can reboot. But in general, a good ballpark for 250 access points and 3,000 users is about 2.5 to 3 hours from start to finish. So I'll do my last check. Let's go ahead and see if the BSSs are up. They're still not up yet, but they will be coming up eventually once everything balances out. So I'm going to go ahead and pause the video, give it another minute or two. Okay, just a quick update. I waited about 2 minutes. I can see the standby tunnels are now up. And so if we look at VMC2, all the active tunnels are over there. All the standby tunnels are on the other controller. And then what we'll see over time is they'll get load balanced across as the controllers have been up and the cluster manager balances things out. So again, the live upgrade process, it's a fairly unique vendor-defining feature, certainly, that allows all of our customers to essentially negate the need to schedule long outages to upgrade their wireless network. They could actually do it in service without taking a major outage. Again, to get there, you go to the node, go to tasks, and go to upgrade cluster, and then from there, you can basically follow the steps. So if you have any questions, certainly reach out to the online help desk or help site at community.arubanetworks.com or reach out to your local Aruba SE or partner. Thank you.